In this video, we are going to solve a problem which is based on the general balance equation of an alternating current bridge or an AC bridge. So let's start with our problem. So our problem is we are given the four impedances of an AC bridge or alternating current bridge, Z1, Z2, Z3 and Z4. Z1 is a resistance of 400 ohm having the phase angle 50 degrees. Z2 is again a resistance of, means these are the impedances value, okay, that is the reactance value given to us. 400 ohm, 200 ohms and phase angles related to them are given to us. If the phase angle is positive, it means it's an inductor. If the phase angle is negative, it means it's a capacitor. And if the phase angle is 0, it means it's a resistance. So here the impedances are the inductors and the capacitors having the phase angle 50 degrees, minus 50 degrees, and their reactance value is given to us. Now we have to find out that whether the bridge is balanced under these conditions or not. So let's try to solve this. If we draw the circuit for an AC bridge, it will be like so in the bridge we are having the four arms A, B, B, C, C, D and D, A, and in the four arms we are having four impedances Z1, Z2, Z3 and Z4. So this is an alternating current bridge, the basic circuit for it. And if we write the balance equation for this alternating current bridge, we know that the general balance equation is given as Z1 Z4 equals to Z2 Z3. This is the general balance equation of an alternating current bridge, and this equation says that the product of the magnitude of the impedances present in the opposite arms, their product is equal to the product of the impedances present in the opposite pair of arms. Okay, so in the circuit, if you see Z1 multiplied with Z4 is equals to Z2 multiplied with Z3. So using this equation, we will find out that whether the this bridge, which impedances values are given to us, whether this bridge is balanced or not, or whether this bridge is following this condition or not. Okay, because this is the balance equation. So to find out or if a bridge is balanced, then it is going to satisfy this equation. Now here, because we are given the phase angles also, so the balance equation for the phase angles is theta 1 plus theta 4 is equals to theta 2 plus theta 3. That is the sum of the phase angles of the impedances present in the opposite arms. Their sum is equal to the sum of the phase angles of the impedances present in the opposite pair of arms. So these two balance equation has to be satisfied by the impedances for the bridge to be balanced. So we are first going to find out Z1, Z4. Z1 is given to us as 400 ohms and Z4 is given as 400 ohms. So 400 multiplied by 400 it will be 1,60,000 ohms. And if we find out Z2, Z3, Z2 is given to us as 200 and Z3 is given as 800. So it is again 1,60,000 ohms. So we can say that the first equation, that Z1, Z4 is equals to Z2, Z3 is satisfied by this bridge, because we are getting the products, both these products, as equal. Okay. Now we have to check the second equation also, because for a bridge to be balanced, both these equations have to be satisfied. So next is theta 1 plus theta 4. So theta 1 is given to us as 50 degrees and theta 4 is given to us as 20 degrees. So it is what? 70 degrees. Next angle is theta 2 plus theta 3. Theta 2 is 40 degrees and theta 3 is minus 50 degrees. So it is coming out to be minus 10 degrees. So we have find out that theta 1 plus theta 4 is not equals to theta 2 plus theta 3. So the magnitude balance equation is satisfied, but the phase angle equation is not satisfied. So we can say that for these conditions or for these values of the four impedances, the bridge is not balanced, because magnitude equation is satisfied but the phase angle equation condition, that is not satisfied. So in this way, if we want to find out that for any bridge, if we are given the value of the four impedances, we can easily find out that the bridge is balanced or not by checking the two balance equations, whether those conditions are satisfied or not. If the equations are satisfied, then the bridge is balanced. If the equations are not satisfied, then the bridge is not balanced. If any one of the equation is not satisfied, then also the bridge is not balanced. So I hope that this problem is clear to you. Thank you.